Now let's discuss Dijkstra's algorithm. It is used to find the shortest path between the two mentioned vertices of a graph by applying the greedy algorithm as the basis of principle. This algorithm can work on both directed and undirected graphs. Now let's code. At first, import library. The heap queue library is imported for priority queue functionality. Now, Dijkstra algorithm function. The Dijkstra function takes a graph and a starting vertex as input. It initializes a priority queue with starting vertex and sets initial distance to infinity for all vertices except for the starting vertex, which is set to 0. Now processing the queue. In a loop, the algorithm pops the vertex with the smallest distance from the priority queue. If a shorter path to the vertex has already been found, it skips further processing. Exploring the neighbors. For each neighbor of the current vertex, the algorithm calculates the distance through the current vertex. If this new distance is shorter than the recorded distance, it updates the shortest distance and pushes the neighbor onto the priority queue. We, we have a build graph function prompts the user to input vertices and edges, constructing a graph represented as a dictionary where each vertex maps to its neighbors and edge weights. And now the main execution. In the main block, the graph is built from user input and the starting node is specified. The Dijkstra function is called to compute and print the shortest distances from the starting node to all other vertices. Now let's discuss the output. At first, we enter the vertices and then we enter the number of edges. After that, we enter each edge, the starting vertex, ending vertex, and the weight. And then, after completion of entering these edges, we enter the start node. And then it gives the shortest distance from the starting node.